So what about this? 3 variables, things that you don't know, and 2 equations. I think a lot of you probably have run across something like this before. So there's a couple ways you can approach this. One, you can't possibly solve for x, y, and z. There's not enough information. Each equation is like a constraint. And you need 3 constraints to specify 3 unknowns. And we don't have it. Geometrically, you can think about this. If you think back to Calc 3, these are planes. So here I have a pair of planes. If they intersect, that is, if they're not parallel, they're going to intersect at a line. So the intersection could be one of 3 things. It could be no intersection, that is, they're parallel, not intersecting. It could be a line, and so an infinity of solutions. Or it could be all x, y, z. That is, they're just the same equation, but there's some multiple of. That's actually pretty easy to toss out. If you multiply the second equation by -3 to get a positive 6 here, you won't get any of the other numbers. So this one doesn't apply to us. But who knows? Maybe it's one of the other 2. So how do we do this? Well, same first step. We're going to make an augmented matrix. It's just not going to be square anymore. So that is, this is not a 3 by 3, it's a 2 by 3. Right? So this is a 2 by 3. It's 2 rows by 3 columns. So what do we do? Well, it's the same thing as before. We'll start with the 1, 1. We want that to be equal to 1. So let's multiply the first row by 1/2. And that'll give us a 1, 2, 3, 2. And the second row is unchanged. All right. Next goal, we want this to be equal to 0, just like before. So what we'll do is we'll take row 2 minus 3 times, 3 times row 1. So it's not going to change row 1. 3 minus 3 is 0. 5 minus 6 is minus 1. -2 minus 9 is minus 11. And 7 minus 6 is 1. Next goal, make this into a 1. So we're just going to multiply the second row by minus 1. So we're not changing the first row. So this is 0, 1, -11. Whoops, sorry, positive 11, -1. Next goal, we got a couple of goals here actually. Let's make this, well, no, make this equal to 0. Okay. So to do that, we're going to take row 2 minus. So if this were a 3 by 3, right, we would be working in the third row, but we're not. So we're back up here. Row 1 minus 2 times row 2. So that's 1 minus 0 is 1, 2 minus 2 is 0. This should be a positive 11. Excuse me. So 3 minus 22 is minus 19. And then 2, this is a minus minus, so this will be a 2. So it's 2 plus 2 is 4. Then we'll have 0, 1, 11, minus 1. Now, from here, it's a little trickier because we're not going to be able to make these equal to 0. That's what, in the problem we had before, we had a 0, 0, 1 in a 3 by 3 matrix, and that allowed us to pick off these numbers. We can't. We're kind of stuck. So let's pause and say, oh, what does this thing equal? Well, it's x minus 19z equals 4. And there's a 0x, so it's y plus 11z equals minus 1. So here's what you do, essentially. A couple options here. Usually, what we'll do is we pick one of these letters, the common one. There should be a common one, z, say. And we're going to say, well, z equals t from now on. We're going to parameterize this. And then solve for x. So then x equals 4 plus 19t. Y equals negative 1 minus 11t. And then z equals t. Whoops. And so what we've done here is to parameterize a line. You might remember doing this in Calc 3. So we expected this sort of solution. There's an infinite number of solutions here. If you pick z to be 0, there's an x and a y. If you pick z to be 1, there's an x and y. If you want z to be 2, 3, 3.1, 3.14, 1.41, and so on and so forth, you can have as many values of x and z as you'd like to have. So we say, well, all right, z can be any number. And so x and y can be any number. But the point of putting it like this is this makes it clear that this is a parameterized line. Yeah. So how many solutions? This is an infinite number of solutions, but not any infinity. All the solutions lie on this line right here. Okay.